High-quality tools should always be used by the mechanic. Quality tools reduce damage to parts, makes the job easier, and lasts much longer than cheaper ones. Some tools are common to most engine work, while others are used only on specific engines or machines. Manufacturers have special tools that are only used on their equipment. A mechanic uses tools every day, and knowing how to identify and use these tools is essential. In this video, you will learn the basic hand tools of the small engine mechanic, as well as some specialty tools used by some manufacturers. There are many styles of wrenches that are used by the small engine mechanic. These include box end wrenches, open end wrenches, combination wrenches, adjustable wrenches, socket wrenches, Allen wrenches, flare wrenches, and torque wrenches. The box end wrench is an excellent wrench due to its gripping power on the nut or bolt. It can either be a 6 or 12-sided wrench and is less likely to slip around the nut or bolt. A 6-sided box end will grip the nut or bolt better than a 12-sided box end wrench. An open-end wrench is a wrench that is open on the ends and only grips two sides of the nut or bolt. This type of wrench is not good for removing stubborn nuts or bolts and will likely slip if used on them. They are only used when a box end wrench or socket cannot be used. A combination wrench has an open end on one side and a box end on the other. This is the most common wrench in the mechanic's toolbox and can be the only wrench needed for the new mechanic. An adjustable wrench is similar to an open-end wrench, except that it can adjust to different size nuts or bolts due to its movable jaws. Just as with the open-end wrench, the adjustable wrench only grips on two sides and can easily round off the corners of the nut or bolt. The jaws should be adjusted to fit the nut or bolt as tightly as possible. Socket wrenches are used to save time and in places that other wrenches cannot reach. There are many varieties available, such as standard or deep length sockets, spark plug sockets, and impact sockets. Impact sockets are special sockets that are used with powerful impact guns to remove stubborn nuts or bolts. They are made thicker and usually flat black. Allen wrenches are used to remove and install hex socket head screws or bolts. They may be angled, straight with a T-handle, or come as a socket wrench. They come in metric and standard, and interchanging the two will cause damage to the screw or bolt. The correct size Allen wrench will fit without any play. The flare or tubing wrench gives a better grip than an open-end wrench because it grips on 5 sides instead of 2. The opening on the 6th side lets the wrench slip over pipes and tubing and still allows the wrench to securely grip the nut. Never use a flare wrench on severely tightened nuts because the jaws of the wrench will be forced open and damage the nut. A torque wrench is used to tighten threaded fasteners to a specified torque. There are 3 basic types of torque wrenches. They are the click type, beam type, and electronic type. The beam type has a pointer that moves across the scale as torque is applied. The click type is first adjusted by turning the handle to the correct specification, then pulling the torque wrench until a click is felt and heard. The electronic type has an electronic scale and is also pulled until a click is heard and felt. Pliers are useful tools for gripping, bending, pulling, and cutting wires. Pliers should never be used to loosen or tighten fasteners since they usually damage the fasteners when used this way. There are many types of pliers, but the basic ones used by the small engine mechanic are locking pliers, usually called vice grips, needle nose, diagonal side cutting, slip joint, and retaining ring pliers. The locking pliers are made so the user can exert great clamping force to increase grip. Many mechanics use them as a last resort to remove hardware that is rusted or frozen in place. Using locking pliers usually damages what they were used on, and the part should be replaced. Needle nose pliers are very useful for bending small wire or gripping parts that are hard to get at. Some also have side cutters built into them for cutting small wire. Diagonal side cutting pliers are used to cut electrical wire or soft metals such as copper or brass. They should never be used to cut hard metals such as steel. Slip joint pliers have a pivot point or fulcrum that can be moved to increase the size range of their jaws. Most slip joint pliers use a mechanism that allows sliding the pivot point onto one of several positions when the pliers are fully opened. Tongue and groove pliers, also known as water pump pliers, are a type of slip joint pliers. They have serrated jaws generally set 45 to 60 degrees from the handles. The lower jaw can be moved to a number of positions by sliding along the tracking section under the upper jaw. An advantage of this design is that pliers can adjust to a number of sizes without the distance in the handle growing wider. These pliers often have long handles, commonly 9.5 to 12 inches long, for increased leverage. Retaining ring pliers are used to remove and install retaining rings on shafts or in round holes. Retaining rings are used on the end of shafts to hold gears in place or inside holes for other purposes. Outside retaining rings must be expanded and inside retaining rings must be compressed. Screwdrivers are used to remove and install screws. They are identified by the type of screw they will be used on, and common types include slotted, Phillips, and Torx. The tip size determines the size of the screwdriver. Proper blade selection is important to reduce damaging the screw you are removing. The slotted screwdriver is designed to fit into a single slot in the screw head. The Phillips screwdriver is used on screws that have cross-shaped recesses on its head. There are different size heads, and the size of the Phillips screwdriver must match the size of the head. The Torx screwdriver is gaining in popularity due to its ability to not cam out of the screw head like the Phillips does. It has 6 sides in a star pattern and can take more torque without stripping the head of the fastener. There are many types of hammers that come in different weights, designs, and are made of different materials. 2 common types of hammers used by the small engine mechanic are the ball peen and soft face. The ball peen hammer has a round flat face on one end and a half face on the other. They come in different weights, with the weight being stamped on the side of the hammer. They are made of steel and are usually used to hit other tools such as a chisel. Ball peen hammers are hard-faced hammers. Soft-faced hammers are used to tap parts that are easily damaged by hard-faced hammers, like the ball peen. They can be made of lead, copper, brass, plastic, or rubber. There are many types of punches and chisels that are used by the small engine mechanic. Whatever punch or chisel is used, the small engine mechanic should strike it with a ball peen hammer and not with a soft-faced hammer. After prolonged use, the striking end will become mushroomed. Pieces of sharp metal will be thrown from the end, and this can be very dangerous. When the end becomes mushroomed, it should be ground down and tapered on the end to remove it. Common types of punches used by the small engine mechanic are center punch, pin punch, and tapered drift punch. The center punch has a point on the end and is used to make depressions in metal prior to drilling. The depression stops the drill from wandering as the drill starts cutting. Pin punches come in different lengths and diameters and are used for driving in or out straight pins, tapered pins, or roll pins. The tapered drift punch is tapered and is used to align holes in mating parts, or to start the process of removing pins so a pin punch can be used afterwards. Chisels are cutting tools used to shear bolts, pins, nuts, rivets, sheet metal, or other material. They have a sharpened end to allow them to cut through metal. Once this end becomes dull, they can be sharpened on a bench grinder. Hacksaws are made to cut metal and are made with a blade that is mounted on a rigid frame. The teeth of the blade should always point toward the front of the saw so it will cut on the push stroke. Blades are available with different amounts of teeth. A fine-tooth blade, such as a 32 tooth, would be used to cut thinner metal, while a coarse-tooth blade would be used to cut thicker metal. Reamers are round cutting tools that are used to shave off metal from the walls of a hole to enlarge it to an exact specification. They are precisely sized to exact tolerances. They are used for jobs such as making valve guides bigger so new guides can be installed. Some reamers are fixed size and are used for precision work, while other reamers are adjustable and are used for jobs that are less precise, like deburring a hole. Files are steel bars with rows of hardened shallow teeth and are used to smooth, shape, or sharpen metal. They can be round, rectangle, square, half-round, or triangle. Files come in different tooth coarseness from fine to most coarse. When using a file, use slight downward pressure as it's moved forward. Lift the file off the part as the file is being pulled back. Files only cut on the forward stroke and can be dulled if they are dragged across the part on the return stroke. Always use a handle on the file when using to avoid injury to the hand or other parts of the body. A vise is a must in the small engine shop for holding parts while they are worked on. Some vices can be swiveled while others cannot. The jaws of the vise are hardened steel and usually have sharp serrated teeth to grip the part. These teeth will leave marks on the parts, and soft jaw covers can be placed over them to protect the part. A gear puller is used for removing gears and bearings from shafts. These are often pressed onto shafts, and the puller has the force needed to remove them. It is not recommended to use a gear puller to remove flywheels, since it could damage the flywheel. A bearing splitter is used while removing roller bearings to avoid damage to the bearing and outer race. There are also bearing pullers that fit inside of bearings so the bearings can be removed from the cases. A flywheel holder is used to hold the flywheel during removal and installation. It prevents the flywheel from turning as the nut is removed or torqued on. When using the flywheel holder, care must be used to prevent it from hitting and breaking engine parts. The ring expander is used to slightly expand the rings so they can be slid over the piston. If the hands are used to expand rings, they become distorted or scratch the piston. The expander applies forces on the rings evenly so they do not become distorted. A ring compressor is a tool that is used to compress the rings so they can be installed into the cylinder. The tool is placed over the piston and tightened until the rings are compressed. The piston rod assembly are then put inside the cylinder and pushed down until the piston is completely installed. A glaze breaker is a tool that uses abrasive stones and is used to lightly roughen up a smooth cylinder to make the rings seal better. It is made up of small abrasive stones of around 220 grit. When properly used, the glaze breaker provides a rougher surface, but will not be used enough to resize the cylinder. They cannot be used to resize or recondition a worn cylinder. A cylinder hone is used to recondition slightly worn cylinders or to finish a cylinder that has been bored, and are usually made with replaceable stones. A flex hone is one type of hone that has stones mounted on spring-loaded arms that keeps the stones pushed against the cylinder walls. Since this type of hone conforms to the cylinder, they cannot be used to correct taper or out of round cylinders. The rigid hone has an adjusting screw that is used to set the hone to a size, and it stays this size until readjusted. This type of hone can be used to correct taper and out of roundness in a cylinder, as long as the taper and out of roundness is not too far out of specifications. A valve spring compressor is used to compress the valve springs so the retainers can be removed from the valve. There are three common types of spring compressors. One type is made of two arms connected at the end with a pivot. The slotted end is put on the end of the valve spring, and the adjustment screw is tightened until the valve spring is compressed. This type of compressor is only used on L-head engines. Another type of compressor is the simple lever. On small engines, it is used only on overhead valve engines and is bolted to the rocker stud. The other hole is placed over the valve retainer, and the compressor is pushed down to compress the valve spring and remove the valve retainer. The last type looks like a C-clamp and has a slotted opening at one end and an adjusting screw at the other. Some of these styles have an added lever that applies pressure to compress the valve spring. The slotted end is placed over the retainer and the adjustable end is placed over the valve head. The screw is tightened and the spring is compressed. The style that uses a lever is used the same way, except the lever is pushed to compress the spring. A valve lapping tool is used to recondition the valves. It is usually made of wood with a rubber suction cup on one end. An abrasive compound is placed on the valve face, and the rubber cup is stuck to the valve head, and the tool is rotated back and forth with your hands until the work is done. Tachometers are used to measure engine speed. There are several different types of tachometers, but the common ones are the vibration and induction tach. The vibration tachometer measures engine speed based on engine vibration. They are placed on the engine and the outer dial is turned until the wire is moving at its widest arc. The induction tachometer uses induction from the spark plug wire to determine engine RPMs. This tachometer can be either clamped to the wire or be wireless, and the unit will display the correct engine RPM. The spark tester is used to determine if the complete ignition system is producing enough electrical voltage to make a spark at the spark plug. The spark tester is connected to the spark plug wire and grounded to the engine. The tester has an adjustable or preset gap built into it. While cranking the engine, a spark is seen between the gap, and this indicates the ignition system is producing enough voltage. The compression tester is used to determine the maximum air pressure inside the cylinder during engine cranking. The spark plug is removed and the compression tester is placed inside the spark plug hole. The engine is cranked with the throttle wide open and the gauge reaches the compression. This will indicate the condition of the valves, piston rings, or cylinder head. Drill motors can either be electric or battery operated and are used to spin assorted tools like drills or screwdriver bits. They have an adjustable chuck that grips the bit and can either use a key to tighten or loosen it or be keyless. The two common sizes are 3/8 and 1/2 inch. The size of the chuck determines the largest bit that it can accept. Most drill motors have a variable speed drive that changes the rotational speed of the bit. The drill press is like a drill motor but are larger and more powerful. They are fixed to a workbench or floor. Care must be taken with any drill to ensure the parts do not spin around and cause injury, so it is important that parts be secured before drilling. Bench grinders are double-shaft electric motors with round grinding stones on each end, or a grinding stone on one end and a wire wheel on the other. They can be used to grind materials down using the grinding wheel, clean parts using the wire wheel, or even polish parts if a buffing wheel is installed. Before using any bench grinder, adjust the tool rest to not more than 1/8 of an inch from the face of the grinding wheel. This prevents the part that is being ground from getting caught in the wheel and coming out toward the operator at a high rate of speed and causing serious injuries. Turn on the bench grinder until it is at full RPMs and slowly feed the part in until it contacts the wheel. Hold the part firmly and keep it in contact with the rest at all times. Micrometers are precision tools that accurately measure parts, such as crankshafts, pistons, and camshafts. There are several types of micrometers, but the common ones the small engine mechanic will use are outside micrometer, inside micrometer, and depth micrometer. The outside micrometer can measure thicknesses and the outside diameter of parts. They are the most commonly used micrometer and can measure piston diameters, camshaft lobe diameters, or wrist pin diameters. The inside micrometer is used to make inside diameter measurements, such as on cylinder bores. The depth micrometer is used to make depth measurements. Though not a commonly used micrometer, the mechanic may need one for his type of work. Digital and dial calipers are handy precision measuring tools that can quickly make inside, outside, or depth measurements. The major difference between the two is the digital uses a digital readout and a dial caliper uses a dial. The digital caliper is also more expensive than the dial caliper. Telescoping gauges are transfer-type measuring devices since they must be used with a micrometer to determine what the measurement is. They are used to make inside measurements such as cylinder bores. They take practice to master and not as accurate as other measuring tools. Small hole gauges are used to measure small holes and are another type of transfer measuring device. Turning a knurled screw at the end of the handle changes the size of the gauge. The small engine mechanic frequently uses them to measure valve guides. Thickness gauges are commonly called feeler gauges and are flat metal leaves that vary in thickness. Each leaf has its thickness etched into it in metric and standard. They are used to measure small spaces between parts such as valve clearances, piston ring gap, and crankshaft end play. Some feeler gauges have round wire leaves instead of flat ones. Round feeler gauges should be used to measure spark plug gaps since flat ones can give an inaccurate reading. The dial indicator is used to measure movement of parts. It can be used to measure crankshaft end play, bent valves, and has many other uses. A thread pitch gauge is used to measure the thread pitch of bolts and nuts. Each leaf is marked with a number that corresponds to its pitch. The tool is placed over the bolt threads until the gauge matches the bolt threads perfectly. Looking at the number on the leaf will give the user the correct thread pitch. They are available in both metric and standard.